Hello and welcome to another session in mathematics. In this session we'll be looking at probability, and our focus will be on independent and dependent events. Okay, but before that, let us take a review of our previous lesson. Welcome back. In today's lesson we'll be looking at independent and dependent events, otherwise known as multiplication law of probability. So let us start with independent events. Independent events. Two events are said to be independent when the occurrence of one has no effect on the other. Okay, it means that the occurrence of S does not depend on the occurrence of what? Y. That's what it means, independent events, when the occurrence of one has no effect on the other. Okay, for instance, if we talk of two balls that are picked one after the other from a bag containing different colors of balls, if the first ball is picked and then before picking the second ball there is a replacement, it means that the picking of the second ball does not affect or depend on the first. Okay, so this type of picking is what we call what? With replacement. We talk of it as what? Probability with what? Replacement. Let's talk of in a football team where we have 11 players from both sides, making it 22 players, total of 22 players. Now if a player is not performing well, then the next thing to do is just to do what? To substitute him or replace him with someone else. Now when you remove one person from this 11 players, it becomes what? 10, and then you substitute someone, still making it the same what? 11, and still the total number of the players is still what? 22. Now we call this what? Independent event. Okay, because it's called what? With a replacement. Now apart from that, we have what we call what? Dependent event. Dependent event. And two events are said to be dependent when the occurrence of one has an effect on the other. For instance, if two balls are to be drawn from a bag having different colors, the first ball is drawn and there is no replacement. If the first ball is drawn and there is no replacement before drawing the second ball, then it is called what? Without replacement. I just give us an instance now in a field where we have 22 players, 11 players from both sides. 11 players from both sides. Now out of this 11, if someone receives red card, if someone receives red card, what happens? The person leaves the field, and then in his team the total number there becomes what? 10 players. Is that correct? Instead of what? 11. And then the total players in the field from both sides becomes 21 instead of what? 22. Now at this point we call this what? Without replacement. He left the field without being what? Replaced, because he received what? A red card. But under substitution, when one leaves, another person comes in, and then we call that with what? Replacement. That's exactly what happens here on probability. So we'll take some examples to explain this further. Let's take example 1. It said a bag contains 6 black balls and 4 white balls. 2 balls were picked without replacement. Without what? Replacement. And he said, what is the probability that A, both are black, B, both are white, C, both are of the same color, D, the first is black and the other white, E, a black and white, and F, both are of different color. Okay, let us start with total number of balls in the bag. Now we have our NS, which is the sample space, to be equal to 6 plus 4, which is what? 10. So we have 10 balls in the bag, and then we are asked to find the probability that the balls that are picked are what? Both black. Now when we are dealing of both, we use multiplication. when we use words like both and the word and, we are talking of what? Multiplication. Okay, then when we use either or, then we are talking of what? We are referring to what? Addition. So both and the word and are used for what? Multiplication. Do we understand now? So for both of these, it means we should find the probability of picking the first one times the probability of picking what? The second one. Now let us start. For our A, if we pick the first black ball, it will be how many? It will be 6/10. Is that correct? Then picking the second black ball, remember there is no what? Replacement. He said it was chosen without what? Replacement. Picking the second ball will now reduce the number of black balls to what? 5, because one has already been chosen. Okay, which gave us this probability 6/10. So now it will now be what? 5/9. 5/9. When you reduce one number from the number of blacks, this is now 5. So 5 plus 4 will give us what? 9. Do we understand? So the first one is 6/10, and then the second one is 5/10, because there is no replacement. So we then have 6 times 5 all over 10 times 9. Okay, 5 can go here to give us 1. 5 can go here to give us 2. 3 can go here to give us 2, and 3 can go here to give us 3. So 2 times 1 we have 2 all over 3 times 2 will give us 6. So we have 2 here, 1, 2 here, 3. So our answer is what? 1/3. 1/3. Okay, let us proceed. For B, let's go over to the next page. We are asked to find the probability that both of them are white. Okay, white balls are 4 in number. Is that correct? So for picking the first white ball, it will be what? 4/10. So this is our B. We have 4/10 times. Then picking the second one, we then have 3/9. Okay, so 4 times 3 will give us what? 12. 10 times 9 will give us what? 90. Is that correct? And then 2 here will give us 6. 2 here will give us 45. Is that correct? 3 here will give us 2. 3 into 45 will give us 15. So we have 2/15. Then let's go over to C. We're asked to find the probability that both of them are of the same color. That the both of them are of the same color. Now the probability of both of them being the same color is the probability of both black plus both white. Do we understand? So that will lead us to having probability of both black plus probability of both white, and then we'll have it to be probability of both black is 1/3 plus probability of both white, which is 2/15, and our LCM is 15. 3 into 15 is 5. 5 times 1 will give us 5, plus 15 into itself is 1 times 2, and that will give us what? 7/15. 7/15. Okay, then we have D. At D, so we should find the probability that the first is black and then the other white. The first is black and then the other white. If the first is black, it will then be what? 6/10. 6/10 times the other white. Remember now, we have how many whites? 4, right? All over what? 9 instead of 10. You know how we got the 9? Because 1 already has been chosen out of the 10 and there's no replacement. So we then have 10 minus 1, which is equal to what? 9. Okay, so let us start. 2 here will give us 2. 2 here will give us 5. 3 here will give us 3, and 3 here will give us 2. Then we have 2 times 2 will give us 4. All over 5 times 3, 15. So we have what? 4/15. Let us go over to E. E, we are asked to find a black and then what? White. A black and white. a black and white. Okay, what does that mean? Here it is not specified whether black or white will come first, as indicated in the question D that we just solved now. So what we are going to do here is to find the probability of first white and then black, then plus the probability of first black and then white. Okay, and that will give us probability of WB plus probability of BW. Okay, let's go over to the next page. We then have probability of WB plus probability of BW. Okay, if we take the probability of white first, white is 4 and black is 6, remember. So probability of white would then be 4 over 10 times 6 over what? 9. Okay, then plus the probability of black first, which is 6 over 10 times 4 over what? 9. Okay, then 2 here will give us 3, 2 here is 5, so we have 4 times 3, which is 12, all over 9 times 5, which will give us 45, plus 2 can go here to give us 2, 2 can go here to give us 5, 3 can go here to give us 2, and 3 can go here to give us 3. So we have 2 times 2, which is 4, all over 5 times 3 is 15. We take the LCM, 45. 45 into itself is 1 times 12. We have 12 plus 15 into this is 3. 3 times this is 12. Okay, so we have 24 all over 45, and 3 can go into 24 to give us 8. 3 can go into 45 to give us 15. So we have 8 over 15. Okay, then we have F, the last question. So we should find the probability that both of them are of different what? Color. Both of them are of different color. Okay, so how do we do that? It's simply 1 minus the answer we got in what? C, because C told us that both of them are the same what? Color. So we'll find the number, the answer we obtained in C, and then we subtract it from what? 1. Then we get the number that they are what? Of different color. So what do I mean? It means our F is equal to 1 minus, what's the value of C? 7 over 15. 7 over 15, and we'll have our LCM to be 15. 1 into 15 is 15. 15 times 1 is 15 minus 7, and that will give us what? 8 over 15. Okay, so let us look at number 2. Nena tosses an unbiased coin and at the same time throws a fair die. Find the probability of getting a tail and a number more than what? 2. So let us start with the sample space. The sample space. If Nena tosses an unbiased coin, she will either get a head or a tail. Okay, and then when she throws a fair die, she will obtain a set of 1, 2, 3, 4, 5, and what? 6. And then the question said we should find the probability of getting what? A tail and what? A head and a number more than 2. So probability of obtaining a tail, which is T, is equal to what? 1 over 2. Since this is 2 and this is 6, tail appeared just once, so it's 1 over what? 2. And then the probability of obtaining a number greater than 2 is equal to, how many numbers are greater than 2? Have 3, 4, 5, and 6. Okay, so we have 4 over 6, and 2 here will give us 2, 2 here will give us 3. Now the probability of obtaining a tail and a number greater than 2 is equal to 1 over 2 times 2 over 3, which will give us 2 over what? 6. 2 here is 1, 2 here is 3, so we have our answer to be what? 1 over 3. Okay, thank you very much for being part of today's class. Before we go, to refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. We've been able to deal with multiplication law of probability, and we'll stop here today. So do well to use the lesson note on the platform for better information on what we've done so far, and feel free to leave a comment or question on the comment section. Till we meet again in our next class, stay safe and bye.